Hi, and welcome to Meetings in Math. You're here for similar triangles. Today, we're going to look at the essential question. Once you have determined triangles are congruent or similar, how can you use that to find missing information about a triangle? You're going to need your Jaguar Jots. On the top, it should say 3.4, something to write with, either a pen or a pencil. A ruler might be helpful and a calculator might be helpful, and always bring your problem-solving skills with you. So let's review what similar means. Similar means that they are the same shape, and that's where this tilde comes from. We use that to say similar, and the same shape comes from the angles. And the sides are proportional. So for example, A is to B is the same as C is to D. So if we look at these, if I can tell you that all of the angles are the same, then I can tell you that this triangle is similar. But we already kind of have a problem here because I'm missing an angle here and I'm missing an angle here, and I'm not quite sure if they are going to be the same. But I do have some good luck. The 58 is the same, so that's good. The question becomes, is X 59 and is Y 43? And I'm not sure. But if they are, this will work. If they're not, we're out of luck. So let's go find out. So let's label this triangle A, and let's label this one triangle B. So in triangle A, we're going to go find the value for X. So we know that the sum of the angles of a triangle are 180 degrees. So 58 plus 43 plus X needs to be 180 degrees. So 58 and 43 is 101. Subtract 101 from both sides. X is 79. We were hoping for it to be 59. That's unfortunate. X needed to be 59, but X equals 79, so X cannot equal 59. That's too bad. Well, let's see what happens in triangle B. We had 58 and 59, and Y is 180. So 58 and 59 is 117. So Y is equal to 63, but Y equals 63, so it can't equal 43. So this is all one great big mess. They can't equal what we wanted them to go to. So remember, we wanted X to be 59, and we wanted Y to be 43. The 58 was okay. So those didn't go to what we wanted them to be. So these triangles are not similar. So therefore, remember those three little dots mean therefore, the triangles are not similar. So all of this other stuff, this is evidence. You could have done it with just box A in the first line or just box B in the first line. That would have been enough, but we were very thorough this time. All right, let's look at the next one. If this works, okay, so we're in good shape with the 52s. Do you see that? That those are equal. If this is going to work, notice I said if this is going to work, X would have to be 80 and Y would have to be 48 if this is going to work. So let's see. Let's start with this box. So we're working on our X's. So 52 and 48 and X equals 180. 52 and 48, 100. X is equal to 80. So far, so good. So we had 52 equal to 52. That's good. We now have X is equal to 80, this one and that one. That's good news. So now let's go do the last one. Make sure it works too. Y plus 80 plus 52 plus 180. So Y plus 132 equals 180. So Y equals 48. I think that's what we were trying to get to. So all the corresponding angles are congruent, therefore the triangles are congruent. Like it. But remember up here we said we really didn't need to do all that work. Same with here. We didn't really need to do all that work. If I know two of my angles, that third angle is going to be, I know what that one has to be because they have to equal 180. So I don't actually have to do all three. I can get away with just doing two. So let's get this, make it a rule. Triangles are similar when they have two pairs of congruent angles. So that's saying you can get away with only doing two of them. So I could have gotten away with just these two right here. I could have gotten away up here with just doing 58 equals 58 and x equals 59. I could have gotten away with just stopping right there and saying, nope, this isn't going to work. So now that we know there's kind of a shortcut, let's look at this one. I don't need to do all of them, do I? I have my 90 right there. And now I just need to get one or the other. So let's go ahead and just do this one and see. And now let's look at this. Let's see if x is equal to 47. So 90 plus 43 plus x equals 47. And if this is true, so now let's use this triangle. 90 plus 43 plus x equals 180. And if my x ends up being 47, I can stop and just say that these are similar triangles. 90 plus 43, 133. X equals 47. So this is enough. I have my 90. I have my x equals 47. That's two angles. So these triangles are similar. So I have 90 equals 90 and x equals 47. So I can say that these triangles are similar. So why do we care? Well, we care because we can use similar triangles to find measurements that are not exactly easy to find. For example, if I'm standing over here on the riverbank and I need to know how far it is across a river, I can actually use indirect measurement to help me find that. For example, I can measure out how far it is here and go 90 degrees and find out how far it is here, and then measure this out. And from that, I can find this distance. Pretty sweet. So let's look at this. We need to know what pieces correspond. So here's my 90. I know from vertical angles, these two angles are congruent, which means from the congruent angle to the 90, those are corresponding pieces. Congruent to the 90, those are corresponding pieces. So we go back to proportional reasoning to help us out. So we know why they're similar. They're similar because we have vertical angles to get those congruent angles and then the 90s. So those are our two congruent angles that we need to prove things are similar. So we can also use, we know that A goes to D, B goes to E, and C goes to C. We can also use those to help us make our proportional reasoning. So we know BC is 2. So I have to go from this triangle to this triangle. So we know BC is 2, B to C is to E to C. And then we need the other side. BA, so BA went to, I'm coming over here to help me, ED, which is good because ED is that length I'm looking for. Right here, that's that length I'm looking for. Okay, so now let's fill in some numbers. BC was 40. BA was 50, EC was 30, and ED is what I don't know. And now I have to solve equations. So we're going to go ahead and use the cross product to help us out. So 40x is equal to 30 times 50. Now we're going to divide both sides by 40. So x is equal to, I'm going to divide both things by 10. So this becomes a 4 and this becomes a 5. 30 times 5 is 150 divided by 4, 37.5 feet. Pretty nifty. So now let's look at one where we don't have any diagram and we have to make our own. A man is standing 3 feet from a bench and the tree is 9 feet from the bench. A man is 6 feet tall. How tall is the tree? So a man Your drawings don't have to be perfect. So can you see the triangle right there? So we have a small triangle that looks like this. Then we have a larger triangle that looks like this. So now here's what we want to know. 3 goes to 9, right? And 6 to x. So let's go ahead and get x on the top this time. So x is 2, 6, because those are in the same idea, right? As, and since we started this one, we have to stay with this one. 9 is to 3. So how do we undo divided by 6? We multiply by 6. So you're left with x is equal to 9 times 6 over 3. I know 3 goes into 6 twice. So x is equal to 18 feet. So that tree is 18 feet tall. So that's it for today. Today we looked at similar triangles. We looked at how to prove that they're similar and then how to use them to find measurements that are hard to do, like climbing up a tree. A little bit hard to do. So thank you so much for showing up. What I would like you to do is I would like you to look at this problem again one more time, see if you can understand it a little bit better, and then be ready to talk about it in class. Thank you so much for showing up, and remember, be kind to each other because we all need a little extra kindness in our lives. And I will see you in our next video. Bye for now.